So this lecture is about supply chain network design. So as a reminder, what is a supply chain network? Well, it is the idea that we need to fulfill customer requests and we need to look back and say, what are all the different things we need to have in place to make sure that the right product is at the right place at the right time? And so that means we need to have retail locations, we need to have warehousing and distribution, manufacturing, and even procurement of supplies. And so that's the supply chain network. And in the next couple of lectures, we're going to talk about supply chain network design. So if we wanted to design a supply chain network, what types of questions do we need to ask ourselves to be able to do that? Well, one obvious question would be, where should we locate facilities? How many facilities should we have? And so when we think about facility location, that could be retail locations, that could be manufacturing facilities, that could be warehouses, any type of facility that's needed in the supply chain network. We need to determine how many should we have and where should they be located. So that's kind of a fundamental question in network design. We'd also need to know, okay, now we know we have these facilities, how should we use them? How should we use those resources? And so questions like that is, what markets should each facility serve? Which supply sources should feed which facility? So these are kind of the arrows in the supply chain network. And so where should we put the nodes and how should we connect the nodes or other supply chain network design questions. Another question you could think about is, what role should each facility play? So just because I have a facility in a certain location, should they be able to make every product you have, or should they be more specialized? What kind of processes should be performed at each facility? That's oftentimes also a supply chain network design question. And then capacity. So how big, how much capacity, how much ability to produce should I have at each facility? So in this class, we're going to really focus on the first two, facility locations, and then how do we allocate those resources, those facilities, to meet demand. The other questions, we're not going to cover a ton in this class. The capacity requires a relatively simple modification to some of the stuff studied in the class. The facility role, I would encourage you to take a facility design class, which we have in our curriculum if you're interested in that part of network design. All right, so let's get started and think about the first question. So facility locations, how many facilities and where should they be located? So what do we think about in terms of facilities? You could think about manufacturing facilities. So like, where should I locate the manufacturing facility? Think about in this area, that could be Regeneron or Global Foundries. They have major manufacturing facilities in our area. Where should they be located? That's a question. You think about warehouse or distribution facilities. So where should I locate those? How many should I have? What should their function be? And then you could also think about retail service facilities. So for example, a mall. Where should a mall be located? If I'm running McDonald's, where should I locate McDonald's or a hotel? And so these are all facility location questions, and companies need to ask these questions about how many and where, but how they answer those questions vary by the type of facility. So typically manufacturing facilities and warehouse distribution facilities, usually we're trying to minimize some cost. Subject to we have the resources we need, but typically there's some cost function. And so when you think about even just by these pictures, they're usually not super pretty areas. They're, you know, where can we locate things that are close to transportation? We have space that's maybe cheaper, etc. Versus retail facilities, there's usually some idea of maximizing a value to a customer. And so when we think about where should we locate and how many facilities we have, oftentimes we think about not transportation cost as much. Instead, we think about, okay, a customer needs to drive to experience this facility. And so it can't be too far away. Otherwise, that would limit the value to the customer. And so these are just general kind of statements, but one of the things I want you to think about is, yes, this idea of how many and where they should be located are extremely generic, but how we decide what is a good solution really would vary based on the type of facility and the type of business that you're running. All right, and so I want to kind of spend some time on distribution. So when you think about distribution in a supply chain network, first of all, what is that? So distribution is the steps taken to move and store a product from the supplier stage to the customer stage in a supply chain. So distribution, I would look at it as the product is built. I now need to get it to the customer. And so what is the facility typically involved in that stage? Is a distribution center or a warehouse. And so when we think about that is if we need to choose our distribution network, we need to look at options, and there are many different options available. They can be really low cost. So you might not have very many distribution centers, but then they're not very responsive to their customer, and there's trade-offs associated with that. And so typically how we would evaluate where should we locate distribution centers or warehouses and how many should we have, there's usually these two dimensions, and it's the cost of meeting customer needs. So we want to minimize cost while providing maximum value. And in today's world, maximum value oftentimes is speed. So if you order anything online, are you willing to wait 2 weeks for your product to show up? Probably not. And so then you wouldn't order from there, right? And so they have to balance the fact that I need to get stuff to you quickly. However, I can't be super expensive. And if you think about the role of distribution in a supply chain, if you mention that in today's world, almost always the word Amazon shows up. Okay, and they really got famous because they really thought about being fast. And so going back to those two metrics, cost and speed to delivery, Amazon has really taken the approach that they want fast deliveries. And so they're making an effort to have one-day shipping be the norm, same-day delivery not so far out of reach. And their supply chain network, specifically their distribution network, is something that's evolving a lot. And I want you to think, how many distribution centers do you think Amazon has in North America? The correct answer is a lot. So this is as of early 2019, they operated over 390 facilities in the US. And if you look at this, the different colors of this map represent different types of facilities. So some are just cross-dock, so they just take in a product and let it go. Some of them are fulfillment centers, sortation, delivery stations, and prime hubs. And so they're not all the same type of facility. They have different capabilities and functions, but there's a lot of them. And so why do they have a lot of them? Because if you think about Amazon, what they promise is fast. They promise speed. And so on this trade-off, Amazon has said, we want to be fast. And so what did they have to do to be fast? Well, they had to spend a bunch of money. And so this is on the y-axis, how much fulfillment capability or capacity. So this is in square foot. So this is how much space they have. And then this on the x-axis is the year that they acquired this. And so you can see they were pretty flat. And then all of a sudden in 2010, they decided, let's build a bunch of facilities. And they actually spent 14 billion with a B dollars to do that. And so this is a good example of the trade-off associated with they wanted to be really fast, so they had to spend a bunch of money on facilities. And so one thing to note is that is a fundamental kind of property in supply chain design or facility location, is if you just have a single facility, that is usually a cheaper solution, but you have slow response time. So if you just had one facility, you could think about reaching the whole US in about a week. But if you had two facilities and you located one on the East Coast and one on the West Coast, you could get to most places in 5 days. So a business week instead of 7 days. But if you're like me, that's still too long, right? And so you may say, okay, I want to be faster as a company. Well, then let's say I can get to almost everybody in 3 days. And this is with ground. So using a mode of transportation like trucking or a carrier service. And you can say, okay, I can get to most people in 3 days. And that may still be too much in today's era. And so you may say, okay, I want 1 day, and you would need 13 distribution centers to get you in 1 day. And one thing to note is not everywhere is able to do in 1 day. So what would you do? Well, you'd probably have to pay for a faster mode of transportation if you said 1 day, or not provide that level of service to all customers. And so to think about this trade-off is you could then say, oh, I want same-day response. That takes 26 distribution centers. So if you remember from the last slide, I had 13. Now I have 26. I doubled the number of facilities. And you can see there's still a lot of places that are not covered by these yellow circles. And so you can see from this why Amazon has so many distribution centers is that they really want to be fast. They want to have same day or next day or 2-day service. And so to be able to do that using a ground transportation network, you need lots of facilities. And so the question in supply chain network design is, how many should I have and where should they be located, right? And so there's actually lots of companies that you can go to them, and a lot of them are consulting type companies that say, I want you to recommend to me where I should locate my facilities, how many I should have, and what is the influence to my transportation costs, to my inventory costs, to my supply chain logistics cost. And so this is a resource that I found from Chicago Consulting, and they basically said if your demand is representative by kind of the US population centers, here are the kind of recommended locations to have distribution centers. And then they say the transit times and average distance to customers. So a couple things that are kind of interesting here is, if you look at here, the number of warehouses, as you go from 1 to 10, the average distance in miles obviously goes down. And you can think about the average transit time in days also goes down. And so average goes down, but the key thing I think that's worth thinking about is average is a statistic that kind of misses some things, right? And so one way maybe that's better to think about this is in a percentile. And so if you think about what percent of the US can you get in next day ground, if you have 10 of them, you can get 92.5%. If I only have one, I only can get 21% of my population. And so if you say, oh, I will give you a 4-day window to deliver, I'm pretty good even just with 2 distribution centers. And so you can see here going from next day, second day, third day, there's a huge jump from second day to third day. And so I don't think it's a coincidence that Amazon said we want 2-day delivery. If you look at these numbers, there's a much bigger jump from second day to third day. So that's interesting, and there is this trade-off, right? So the more warehouses you have, the more expensive, and we'll talk about that as well, but you have better response time. And the other thing that they did is they said, as a rule of thumb, here's some good locations. So where should I put these 10? And they recommend these places. And so how did they get these 10? They used likely some optimization methods, which we'll talk about in this class. But then they also looked and said, are they close to an interstate? Can they move things fast? Is there a population of people that could be a labor force for them, etc.? And so if you look at these, and if you know anything about distribution, like Lakeland, Florida is basically a distribution town. The town is designed with tons of distribution centers. And so they used a combination of optimization, math, but also combined that with other factors throughout to understand this. And this is, again, a kind of rule of thumb. It's based on kind of generic demand data. And so one thing you could think about, if you like the stuff we're talking about, there are companies that this is what they do as consulting, is they figure out where should I locate your facilities. And usually they're using specific demand from companies and specific transportation costs, et cetera, to make these decisions. All right, so as kind of as motivation, what does this all mean? And so the main takeaway is, if you think about the x-axis is the number of facilities, as the number of facilities gets bigger, our response time goes down, okay? So as we have more of them, we get closer to the customer, we can be faster. That hopefully makes sense. As the number of facilities increases, we get this like bathtub total logistics cost, okay? So we will exploit that, kind of dig deeper in why do we get this like bathtub curve for total logistics cost. All right, so if we think about the number of facilities again on the x-axis, and now on my y-axis, I have inventory cost. This curve you should hopefully recognize from our inventory lectures. What is this curve? This is the square root of the number of facilities. So as a reminder from our inventory knowledge, as we increase the number of stocking locations, our safety stock increases by the square root of the number of facilities. Again, this is a rule of thumb based on what is our correlation between markets, etc. But this is kind of a typical generic increase. So as we have more facilities, we should expect to have more inventory, specifically safety stock inventory, but it's not a linear increase, it's a square root increase. Okay, so that's the inventory cost. So as we have more facilities, that's not good for inventory. But if we have more facilities, that is good up to a point for transportation. So what is happening here? Again, the x-axis is number of facilities. The y-axis is the transportation cost. And so what is happening here is, as we have more facilities, we're getting closer and closer to our customers. And so that means we don't have to spend as much to pay for transportation, or we can say we're driving less, right? So that's cheaper. We also may say we're using cheaper modes of transportation. If we have a 2-day window, maybe we can drive it to them. We don't need to use air, which is more expensive. And so that's why this graph is going down. But it goes down up to a point and then it starts going up. And what is the part that's going up is the inbound side. So when you think about supply chain network design, the least efficient part of the transportation side is at the customer end. Why? Because we're not efficient. We're sending one package to someone's door. Whereas what's coming into a warehouse is a full 40-foot trailer full of goods. And so yes, as we have more of these locations, we may have more transportation that's coming in, but that transportation costs are more efficient per unit than what's going out. And so for the most part, as you increase your facilities, your transportation cost goes down. At some point, if let's see an extreme example, you had a distribution center for every customer that you ever had, well, then you have a problem because the inbound all of a sudden gets inefficient. And so for the most part, most companies never get to where this is going up. They have much fewer number of facilities compared to customers. And so that's the normal aspect, is that transportation goes down as the number of facilities goes up. All right, and so then if you think about, again, on the x-axis is the number of facilities, but on the y-axis is facility cost. As the number of facilities goes up, you could think about our facility cost going up, okay? And so that hopefully should make some sense. If you have only one facility, typically it's bigger. If I have 2 facilities, maybe they're a little bit smaller, but there's fixed costs regardless of the size. And so this goes up over time. And why is it flatter kind of over here than it is here? Is that potentially at some point, if you have such a big facility, maybe you need 2 of things anyways, 2 managers, etc. And so if I go and break them into 2, it's a little more expensive, but not that big. But if you go way over here, you're basically saying I have a really small facility and I have to have a manager, a roof, all these fixed costs for that. And that's why this is much steeper than over towards its side. And one thing to emphasize with these graphs is they're generic. If you had a real company, you would input different cost parameters and make your graph specific to your company. But typically there is this trend that happens. All right, so now if I combine all of those, that's where you get this bathtub curve. So inventory costs do this, transportation costs do this, facilities go there, and if I sum them all up, what are you doing? Well, you get this bathtub-like curve. And so what we're trying to do is we're trying to minimize logistics costs and have a reasonable response time. So typically what people will say is we need our response time to be at most 3 days. And so you would go on this curve and say, where is 3 days? And then you'd say, okay, this would be the number of facilities. As long as the total cost is kind of on the bottom where this is pretty flat, that works. If you're over here and you say, my response time needs to be less than 1 day, but now my total cost is here, you may have another conversation. Is that really the service level I want to set? So that's how this curve would be used. So if you kind of step back from all of that, why is supply chain network design interesting? It's interesting because it's a hard decision. And why is it hard? Because there's lots of trade-offs involved. And so I would say one of the best ways to think about decision making is to think about what is good and what is bad. And typically the most interesting decisions have a little bit of good and a little bit of bad. And that's true with the decision of facilities. So if we just think about increasing the number of facilities, if I go from 1 to 2 and so forth, that's good for responsiveness. So that means I'm closer to my customer, which also means it's good for transportation costs. However, that's bad for efficiencies and bad for inventory costs. And so where do I make that trade-off? That's where it's useful to use optimization. It's useful to use quantitative methods, which is what the rest of the semester will talk about. So here's my first kind of conceptual question for you. So we talked about facility location, and a facility could be a warehouse, it could be a retail center, it could be a manufacturing facility. What do you think? Locating a facility is it A, a strategic decision, B, a tactical decision, C, an operational decision, or not a decision in supply chain management? I hope you picked a strategic decision. So when you think about locating a facility, it is a strategic decision. Why? Because once you decide where something is located, that is typically a long-term fixed commitment. So if you think about going and saying, I'm going to have a manufacturing facility in Rensselaer County, the amount of financial commitment, the amount of management commitment, et cetera, is long. And so what that means is once I decide where I should locate my facility, many costs that come with supply chains then are fixed and difficult to change. And so one implication of that is that a facility decision, oftentimes it's worthwhile spending resources and time and effort to really think about what should my decision be. And so that is why we can justify spending resources and time to make, for example, an operations research model, an optimization model, which we'll talk about in this class. That's why there are these consulting companies that exist. That companies go to them and say, what should my facility network look like? What should be my supply chain network? That's because once they make those decisions, many other decisions that a company needs to make are oftentimes very difficult to change and are then kind of fixed based on what happens with my facility location decisions. One example of that is transportation costs. And so when you think about transportation costs, I think it's interesting to think about how transportation has evolved. So this is more just something I think is super fascinating. So if we think about this graphic, this is the rate of travel in 1800. And so if you think about from New York City to get to where we live in Albany, Troy area would take, I don't know, almost a week. And so thinking about the fact that we get products delivered to our house in days, in 1800 would have been like, you guys are crazy, right? And so to think about even just getting to midway in the middle of the country would take 6 weeks. And so if you think about facilities and what was happening back then in terms of supply chains, is that the supply chains were not nearly as centralized as they are today. And they also weren't as accessible. So oftentimes you didn't always get food from all over the world or even all over the country. You ate much more regionally. And so one thing I think is interesting is, okay, now in 1930, so zoom 130 years forward, this is when we get railroads in the country. And so when you think about from New York City, we can now get all the way to California in 3 days. And so that's quite amazing compared to the previous chart graph. And then today, if you think about what's going on, this is for courier delivery. So you think about the UPS or FedEx. As we look at the x-axis here is the number of locations. So let's say we had one location and it was in, let's say, New York City. We can get to about 20% of the population through 1 day ground. But if we have 2 days, we can get to whatever, 60%. If we have 3 days, I don't know, 85%. And so it is quite amazing how fast we can deliver things, even with a relatively few locations. And that has to say a lot with transportation and the transportation companies and the transportation infrastructure that's been built in this country. So that I will kind of stop here for motivation, and the rest of this slides will talk more about, okay, how do we actually make these decisions? How do we determine how many and where to locate?